June 1944. The dawn mist hangs low over the English Channel, glowing faintly under a blood-orange sunrise. The wind tastes of salt and diesel. On the quiet shore of the Isle of Wight, dozens of men in oil-stained uniforms work without a word. They move with precision, slow, deliberate, secretive. From a distance, it looks like any other coastal repair. But beneath the rhythmic clang of steel and the murmur of radio chatter, something extraordinary is taking shape. Massive drums, each taller than a man, begin to turn, unspooling thick black cable into the sea. What appears to be cabled is, in truth, a lifeline, a secret artery meant to feed an entire army. Behind barbed fences, engineers from Britain and America oversee the process. Every bolt, every weld, every meter of pipe is classified. Even the local fishermen have been told nothing. Somewhere beyond that horizon, the beaches of Normandy burn with battle, and while the world watches the soldiers fight, these men are preparing the fuel that will keep them moving. By the summer of 1944, the Allies had achieved what many thought impossible. The beaches of Normandy were theirs, but victory on the sand was only the beginning. The real war, the one fought in supply lines, depots, and fuel drums, was about to begin. Every tank that rolled inland, every truck that carried rations, every aircraft that circled above, all burned fuel. Gallons of it, tens of millions each week. And for every mile the Allied spearhead advanced across France, the distance from the nearest fuel source grew wider. Before D-Day, Allied planners had filled the English countryside with fuel dumps and depots. Giant tank farms near Portsmouth, Southampton, and Bristol brimmed with aviation gasoline and diesel. Tankers ferried fuel across the channel in steel drums and flexible bladders. But those methods were painfully slow, vulnerable, and limited by weather. One German submarine, one storm, could sever the entire flow of supplies. The British chiefs of staff had learned the lesson of Dunkirk all too well. Victory was not won by courage alone, but by logistics. And logistics ran on oil. By early 1942, even as the Allied invasion was still a dream, British engineers had already begun sketching ideas for something revolutionary: a pipeline under the sea. It sounded absurd. No one had ever attempted to run pressurized fuel through pipes stretching across dozens of miles of cold, shifting seabed. Yet the alternative, hauling millions of barrels in vulnerable tankers, seemed worse. Winston Churchill understood this better than most. He had long admired bold engineering solutions, especially those that defied convention. "Without oil," he once said, "the operations of modern war are impossible." And so he demanded a plan, one that would keep the invasion fueled no matter how far the armies advanced. The problem was as technical as it was strategic. Fuel needed to be transferred continuously, quietly, invisibly. If the Germans discovered the plan, they could destroy it with one bombing raid. Thus, secrecy became as vital as steel. Early proposals came from two unlikely groups: British cable manufacturers and the Petroleum Warfare Department. One team believed the answer lay in adapting undersea communication cables, strengthening them to carry fuel instead of telegraph signals. Another team, led by engineer Arthur Hartley of the Anglo-Iranian Oil Company, envisioned welding rigid steel pipes together and laying them along the seabed using specially modified ships. The code name would soon be chosen: Operation PLUTO, short for Pipeline Under the Ocean. At the time, even the name sounded like science fiction. But in the backrooms of London and the workshops of Manchester and Southampton, the impossible began to take shape. To the engineers, the challenge was staggering. Seawater pressure could crush pipes, temperature shifts could cause ruptures, and constant movement of the tides threatened to twist and break the line. Yet, slowly, through hundreds of small experiments, the vision solidified. By late 1943, two competing pipeline types had emerged: the Hayes pipe, a flexible lead-lined cable developed by Siemens Brothers and the National Physical Laboratory, and the Hamel pipe, a rigid steel line designed for faster laying in shallow waters. Both would play their part in feeding an army that, before long, would surge across Europe. But first, they had to prove it could work at all. The idea of building a 70-mile-long pipeline in secret, across one of the world's busiest and most dangerous stretches of water, would require not only innovation, but silence. And as winter turned to spring, while Allied generals rehearsed the coming invasion, a smaller army of engineers, welders, and planners prepared their own D-Day. Because without them, without their secret arteries pulsing beneath the channel, the great liberation of Europe might have stalled before it ever began. By early 1944, the Allies were deep in the final stages of planning Operation Overlord, the largest amphibious invasion in history. Every landing craft, tank and aircraft required a staggering volume of fuel. Yet few outside a small circle inside the Petroleum Warfare Department knew how that fuel would reach the mainland once the beaches were secured. For the men working under British engineer Sir Donald Banks, secrecy was absolute. Only the initials PLUTO appeared on official paperwork, and even that was disguised as a routine cable-laying project. Inside nondescript buildings across southern England, machinists, chemists, and welders labored around the clock, producing materials they didn't fully understand. Two competing pipeline types were now in motion. The HIIS pipe, designed by Siemens, Brothers and Callender's Cable and Construction Company, was a marvel of electrical cable design repurposed for war. Its structure was deceptively simple: a lead core for strength and flexibility, wrapped in layers of steel tape and tarred jute. It could be wound onto huge spools and laid like telegraph cable, allowing it to snake across the seabed without breaking. The second type, the Hamel pipe, developed under engineer H.A. Hammock and B.E. Latimer, used welded steel segments. This was more rigid but ideal for shallow crossings and rapid deployment close to shore. Together, they offered versatility: Hayes for deep water, Hamel for coastal runs. By spring 1944, British industry was fully mobilized. Steel mills in Middlesbrough rolled thousands of tons of pipe. Cable factories in Kent and Woolwich worked under tight supervision, producing miles of the heavy Hayes line. Each segment was inspected with X-ray precision. A single flaw could rupture under pressure. The next challenge: laying it. Cable-laying ships, previously used for undersea telegraphs, were modified for war. The most famous was the HMS Latimer, fitted with massive steel drums capable of carrying over 30 miles of pipeline. New vessels called conundrums, giant floating spools, were invented to deploy the heavier Hamel pipe. These rotating monsters, 30 feet in diameter, looked more like something from a science fiction film than a naval operation. Meanwhile, along the southern coast of England, entire pumping stations were camouflaged to look like seaside cottages, ice cream shops, or farmhouses. Inside these quiet facades were powerful Pettifer pumps, capable of forcing thousands of gallons of fuel per hour through the pipeline network. Their locations were known only to a handful of officers. Testing began in secrecy off the coast of Scotland. The first trial, between the Isle of Wight and the mainland, ended in disaster when pressure ruptured the pipe. But instead of failure, it served as a lesson. Engineers adjusted the pipe's internal layering, improved the welding process, and developed new buoyancy controls for the laying ships. By May 1944, a 30-mile test between Southampton and Shanklin succeeded. The pipeline carried aviation fuel continuously for 10 days, an engineering triumph that would soon change the war. Operation PLUTO was approved for full deployment. Two main routes were chosen: Bambi, running from the Isle of Wight to Cherbourg, designed to supply the American forces after D-Day; Dumbo, running from Dungeness to Boulogne, intended for the British and Canadian sectors once northern France was secured. Both would be expanded inland to follow the Allied advance through Normandy, across Belgium, and into Germany itself, an underground highway of fuel. Still, the risks were immense. A single German reconnaissance flight spotting those massive drums on deck could unravel years of secrecy. Weather in the Channel was unpredictable, and underwater obstacles could tear the line apart. But time was running out. As D-Day approached, men who had never seen battle prepared to perform an operation as dangerous as any assault. Laying the pipeline meant sailing slowly, steadily, in range of enemy aircraft and submarines, all while dragging thousands of tons of steel and fuel line across a living, shifting sea. And so, while paratroopers rehearsed their night drops and soldiers marked the beaches of Normandy on maps, another force waited in silence. Engineers, sailors, and technicians whose weapons were wrenches and blowtorches. They would strike after the invasion began, in total secrecy, under the cover of the world's most chaotic battlefield. The invasion was only days away. The Allies were ready to storm Europe, and the lifeline that would feed their armies was ready to follow them beneath the waves. They were not soldiers in the usual sense. No medals, no parades, no frontline heroics. Most were engineers, welders, ship crews, and factory laborers, men and women who worked with steel, copper, and oil instead of rifles. Yet, in the silent shadow of Operation PLUTO, their contribution was as critical as any combat unit storming Normandy. Inside Britain's industrial towns, Glasgow, Manchester, Woolwich, entire workshops were commandeered for secret production. Workers were told only that the project was essential to invasion success. They labored 12-hour shifts, 7 days a week, cutting and welding steel that would soon rest at the bottom of the channel. A machinist named Arthur Bridge, who later spoke about his experience, recalled that the factory windows were painted over to prevent light leaks. "We didn't know what we were making," he said. "We just knew it had to be perfect." At sea, the men laying the pipeline faced a different kind of danger. Aboard ships like HMS Algerine and HMS Holdfast, cable crews worked in silence as the conundrums turned, releasing the black pipeline into the waves. They moved slowly, no more than a few knots, completely exposed to enemy detection. One U-boat sighting could have ended the mission instantly. When weather shifted, waves smashed against the decks, and the steel line groaned under strain. If the pipe snapped, it could whip across the deck like a blade. More than one man lost his footing, or worse. And yet, despite the risk and exhaustion, morale remained astonishingly high. Letters home spoke of pride more than fear. "We're not fighting," one sailor wrote to his wife, "but every drop we send through those pipes keeps the tanks rolling. That's good enough for me." Back on land, the pumping stations came alive with sound. The rhythmic hum of engines, the hiss of valves, the faint vibration of pipes buried beneath sand and concrete. It was mechanical music, proof that their invisible network was alive. No frontline glory, no famous headlines. But when Allied fuel trucks filled their tanks in France, the men who built those lifelines knew, somewhere beneath the channel, their work was flowing. The genius of Operation PLUTO lay not in sheer scale, but in adaptation, turning peacetime technology into wartime weaponry. The HAI's pipeline, born from British telecommunication expertise, was a marvel of applied physics. Engineers took the concept of undersea cables and re-engineered it for a new enemy. Not distance or data loss, but pressure and corrosion. The lead core, once designed for copper wire, was now strengthened to withstand the pounding tides. Around it, steel tapes and tarred fiber formed a flexible armor. Each mile of HAI's weighed nearly 50 tons. It could be spooled onto a drum 30 feet wide, then unwound like thread into the ocean. The precision required to keep pressure constant, around 1,500 pounds per square inch, was astonishing. One leak could shut the entire line. Then there was the Hamel pipe, a triumph of simplicity and brute force. Rigid steel tubes welded end to end, each section tested and sealed. To lay them, the Royal Navy invented the conundrum, a floating drum that could unroll the pipe as it was towed slowly across the channel. At first, these structures seemed absurd. Naval officers joked that they looked like Noah's spare wheels. But when the first conundrum turned under full load, spooling miles of pipe into the sea without failure, silence fell across the deck. The impossible was now real. On shore, the pumping systems were equally advanced. Pettifer pumps, powered by massive Rolls-Royce engines, could push over 500,000 gallons of fuel a day. The pressure control required mathematical precision. Too low, and the flow would stop. Too high, and the pipeline could explode. Beneath their feet, the engineers had created a living artery, a pressurized, responsive system stretching from English ports to French fields. And remarkably, all of it operated with a secrecy so tight that even most Allied soldiers refueling in France never knew where their fuel came from. In an era before digital controls or satellite imaging, Pluto represented something else entirely: the purest form of ingenuity, problem, risk, and relentless adaptation. This was not technology built for fame or profit. It was built for necessity, for the desperate mathematics of war, where 1 gallon of fuel could mean 1 more mile toward liberation. And while these pipes carried gasoline, they also carried something else: proof that victory would not be won by strength alone, but by the precision of minds working in silence. For the Allied command, Operation Pluto was more than engineering. It was strategy distilled into steel. Fuel meant mobility, and mobility meant power. By mid-1944, as Allied forces pushed beyond the beaches, fuel convoys struggled to keep pace. Every day, hundreds of tankers risked the channel, each one a floating target for German aircraft or U-boats. At the same time, millions of fuel drums clogged the temporary harbors at Arromanches and Omaha, creating logistical chaos. Pluto changed everything. Once the first HAI's pipeline began pumping from the Isle of Wight to Cherbourg, the flow of aviation gasoline became steady, invisible, and safe. It could deliver over 1 million gallons a day directly into Allied depots behind the front lines. The pipeline transformed the way commanders planned their offensives, no longer chained to vulnerable sea convoys. When General George S. Patton's Third Army broke out from Normandy in August 1944, his tanks consumed an astonishing 400,000 gallons of fuel per day. The underground arteries of Pluto made that possible. The pipelines followed the armies eastward, extending deeper into France and Belgium. It was quiet power, no roar, no spectacle. Yet without it, the liberation of Europe might have stalled in the mud. Pluto's true victory was logistical, a triumph that turned fuel into freedom. If Germany had discovered Pluto before its completion, the consequences could have been catastrophic. A few well-placed bombs could have severed the Allies' lifeline before it even began, so secrecy became as vital as steel and oil. Every aspect of the project was disguised. The pumping stations were camouflaged as seaside buildings: a quaint ice cream parlor in Sandown, a fisherman's cottage near Shanklin, a nondescript boathouse in Dungeness. Behind these facades, deafening machinery pumped thousands of gallons of petrol every hour. Even local villagers believed these were ordinary coastal facilities. Personnel were compartmentalized. Engineers knew their section, never the whole system. Documents used vague code names. Maintenance schedules were hidden within unrelated naval paperwork. Only a handful of officers at the Petroleum Warfare Department and Supreme Headquarters Allied Expeditionary Force, SHEF, understood the full scope. Security patrols guarded the sites day and night. German reconnaissance planes occasionally passed overhead, but the camouflage held. Aerial photos revealed nothing more than sleepy English cottages and fishing huts. Even after D-Day, the secrecy continued. When the first pipelines were laid, they were recorded in logs as telecommunication cables. Only when the first pump engaged, sending fuel surging across the channel, did the full reality dawn on the few who knew. In the chaos of war, invisibility became protection. Pluto succeeded not because it was indestructible, but because the enemy never knew it existed. It was, in every sense, a secret victory. One fought not with guns or bombs, but with silence. Behind the machines and maps stood leadership, the kind that valued intellect over glory. Winston Churchill, though deeply involved in the war's grand strategy, took personal interest in the project's progress. He often reviewed reports from the Petroleum Warfare Department, urging the engineers to make the impossible commonplace. His trust in civilian expertise reflected one of the Allies' greatest strengths, the unity of military command and industrial talent. But the real moral backbone of Pluto lay with the lesser-known men who led its creation. Sir Donald Banks, Arthur Hartley, and Lord Louis Mountbatten Banks, a civil servant with no military background, organized the teams and resources with relentless precision. Hartley, the chief engineer, solved problem after problem under unrelenting deadlines, often sleeping in the workshops beside his men. Mountbatten, as chief of combined operations, shielded the project from bureaucratic interference, ensuring secrecy and funding remained intact. Their leadership style was defined by quiet confidence. They didn't need the spotlight. Their success would be invisible by design. And they knew the stakes. If Pluto failed, Allied tanks would grind to a halt in France, and the invasion could collapse. It was leadership built not on orders, but on trust, between scientists, naval officers, and workers who understood that the true measure of war was not only in battles won, but in the invisible systems that made them possible. When the first fuel finally flowed under the sea and reached Allied hands in France, there were no speeches, no celebrations, just a message transmitted through coded channels, pump running, pressure stable. It was a small sentence, but one that carried the weight of an empire's hope. August 1944. The beaches of Normandy were now gateways to Europe. The battlefront stretched hundreds of miles inland, from the hedgerows of Caen to the river crossings near Le Mans. The Allied advance was relentless, but it was also dangerously thirsty. Tank divisions burned through fuel faster than it could be delivered. Convoys of trucks snaked along makeshift roads, carrying barrels from beach depots to the front. Each delay, each lost truck, meant tanks standing idle and aircraft grounded. In London, reports grew alarming. Eisenhower's staff warned that fuel shortages were threatening to slow the entire advance. The German army was retreating, but if the Allies paused even briefly, they might regroup. The order came quickly and without ceremony. Get Pluto operational. On the Isle of Wight, the first great test was about to begin. In total secrecy, under the coordination of the Petroleum Warfare Department and the Royal Navy, the final Hayes pipeline had been wound onto its massive steel drum. It was time to cross the channel for real. The ship HMS Latimer, heavily modified for cable laying, eased out of port under gray skies. On its deck, engineers checked pressure gauges and radio lines. The pipe, thick, tarred, gleaming with seawater, began to unwind, slipping slowly into the waves. For 70 miles, the black line vanished into the depths, curling gently along the seabed between Isle of Wight and Cherbourg. The operation moved at walking pace, 3 knots, a vulnerable crawl through one of the most dangerous waters in the world. A single U-boat could have ended everything. German submarines still prowled the channel, hunting supply ships and landing craft. The men on deck stood in tense silence, scanning the horizon. Even a rumor of periscope sightings sent hands tightening on lifelines. But hour by hour, mile by mile, the work continued. By dusk, the pipeline reached the French coast. Naval divers confirmed the connection points, and the final welds were sealed. Then came the moment of truth. In a small camouflaged building at Sandown, the pump station came alive. Motors hummed, valves opened, and a deep mechanical growl filled the room. Pressure climbed, 500, 800, 1,200 better. The pipeline shuddered under strain. Somewhere beneath the channel, a column of fuel began its journey through the darkness. Minutes passed. Then an operator at Cherbourg radioed 2 words that silenced the room. Fuel received. Applause broke out. Engineers who had spent years in secrecy, men who had risked their lives without recognition, finally saw proof that their creation worked. For the first time in history, fuel was flowing beneath the sea. The achievement was staggering. The first Shays pipeline delivered 56,000 gallons per day, enough to sustain hundreds of vehicles. Within weeks, more lines were added, each one increasing capacity, each one buried deeper under the seabed to avoid detection. But success did not mean safety. The pipelines were fragile. Storms tore at the seabed. Pressure surges ruptured sections. Marine life interfered with joints. The men tasked with maintenance often had to sail under enemy threat to patch leaks in mid-channel. And on land, the front advanced faster than expected. As Allied forces liberated Paris and pushed toward the German border, fuel demands skyrocketed. What had begun as an experiment now had to become a full-scale industrial system. By September, a second major route, Operation Dumbo, from Dungeness to Boulogne, came online. It was shorter but capable of carrying heavier flow. The two networks combined created a vast invisible infrastructure, a twin artery of oil beneath the channel. Every gallon that reached the pumps in France carried not just energy, but hope, proof that Allied logistics could outpace the German retreat. The British Ministry of Supply called it the most effective secret weapon in Europe. On the front lines, few soldiers knew of its existence. They only saw the results: fuel trucks arriving on time, planes refueling without pause, tanks rolling day after day across open country. Behind that relentless motion was Pluto, pulsing silently under the waves. And yet, for all its success, the system was still at risk. Each new advance demanded longer pipelines, deeper crossings, and faster output. As autumn rains turned roads to mud and German defenses stiffened along the Siegfried Line, the Allies faced a new question. Could Pluto stretch far enough, fast enough, to keep the armies moving? The answer would decide the pace of Europe's liberation. Autumn, 1944. Europe was burning itself toward conclusion. From the fields of Normandy to the plains of Belgium, Allied divisions pressed forward, their columns stretching for miles. The world's largest mechanized army now moved almost entirely on the strength of its fuel. Every tank, every jeep, every bomber, all depended on a continuous stream of petrol. Without it, momentum would die, and in a war of movement, to stop was to lose. In September, as American and British forces raced through liberated France, the engineers of Operation PLUTO began their next great challenge: expansion. The first Hayes line from the Isle of Wight to Cherbourg had proven that the concept worked. Now they needed scale, more pipelines, longer routes, greater capacity. At Dungeness, Kent, teams worked day and night to prepare the Dumbo line, a shorter but heavier-duty route to Boulogne. The beaches of northern France were still scattered with wreckage from D-Day. Yet within weeks, the pipeline began to unspool beneath the waves. By early October, fuel was pumping at an astonishing 1 million gallons per day. The system became the unseen heartbeat of the Allied war machine. From Boulogne and Cherbourg, underground pipes stretched inland to massive depots at Arras, Amiens, and Antwerp. From there, truck convoys carried the fuel to the advancing armies. General Patton's Third Army, often criticized for its reckless pace, could not have sustained its drive toward the German frontier without Pluto. In one of his reports, Patton's logistics officers noted simply, "The flow from the Channel has not failed." Even as Allied engineers extended the network across the devastated French countryside, the Germans remained unaware of its true nature. Luftwaffe reconnaissance occasionally captured images of the coastal pumping stations, but their camouflage was flawless. The enemy assumed they were ordinary naval installations. By November, over 17 undersea pipelines connected Britain and France. The longest stretched more than 70 miles, and the entire system, including onshore branches, totaled over 1,200 miles of pipe. It was, by every measure, one of the most ambitious engineering projects of the war. But it was not without crisis. In late October, storms swept the channel, tearing loose several exposed segments. Divers worked in freezing water to locate ruptures, guided only by sonar and flashlight. One ship, the Empire Baffin, nearly capsized during a repair mission when a conundrum broke free in high winds. Still, they persisted. Every hour of delay meant dwindling supplies for the armies pushing east. Meanwhile, Allied troops reached the borders of Germany. The Siegfried Line, Hitler's defensive wall, loomed ahead. The offensive that would pierce it, and later cross the Rhine, would consume more fuel than any previous operation in Europe. The logistics teams knew what that meant. Pluto had to be extended again. Engineers surveyed new routes across Belgium, designing inland connections that linked the Channel supply to newly liberated ports. Fuel storage farms sprang up overnight, enormous steel tanks hidden in forests and quarries. Trains and trucks carried the flow onward, all fed by the steady pulse from beneath the sea. In December 1944, the German counteroffensive in the Ardennes, the Battle of the Bulge, momentarily threatened to cut Allied supply lines. As snow blanketed the front, the demand for fuel soared again. Yet even then the pipelines held. Despite storms, sabotage fears, and exhaustion, the fuel never stopped. By January 1945, more than 180 million gallons of fuel had been delivered through Pluto. The system's capacity had multiplied tenfold since its first run 6 months earlier, and it would continue to expand, quietly, efficiently, until the war's end. When Allied troops crossed the Rhine in March 1945, the pipelines were still delivering. Engineers joked that the fuel flowing into Germany had started its journey months earlier, under the English coast. That victory itself was being pumped through steel veins beneath the sea. The achievement was invisible to most who benefited from it. To soldiers, fuel was simply there, waiting in drums, tanks, and refueling depots. Few ever imagined it had traveled under an ocean to reach them. But in quiet naval command rooms and secret workshops, the engineers who had once been dismissed as dreamers knew what it meant. They had turned an idea, a sketch on a wartime paper, into a living system that had powered the liberation of Europe. And as the armies rolled into Germany and the Third Reich began to crumble, Pluto continued its steady, silent work, pumping the lifeblood of victory, unseen. Unstoppable. May 1945, Europe lay in ruins. The war that had consumed the continent for nearly 6 years was over. From Berlin to the Channel coast, Allied convoys rolled through the wreckage of the Reich, their engines still humming, powered by the same invisible network that had sustained them since Normandy. Operation Pluto had done its work. When the figures were finally compiled by the Petroleum Warfare Department, even the most seasoned logisticians were astonished. In less than a year of full operation, Pluto had delivered over 180 million gallons of fuel, nearly 1 million tons, from Britain to the Allied armies in Europe. At its peak, the network pumped 1.1 million gallons per day, an unbroken stream of energy that crossed the Channel like a buried artery of victory. That fuel powered everything, from the Sherman tanks that breached the Siegfried Line, to the trucks that brought food and ammunition, to the bombers that struck deep into Germany. What made these figures even more remarkable was how quietly they were achieved. No formal announcement, no newspaper coverage, not even a public acknowledgement during the war. The men and women who had built and operated Pluto knew they could never speak of it. Not yet. Official reports praised the efficiency of fuel delivery systems, but the name Pluto remained classified. Even within the military, most officers believed their supplies arrived via standard tanker routes. The operation's very success depended on its invisibility. But inside the Petroleum Warfare Department, a quiet satisfaction settled in. Engineers reviewed their maps and flowcharts, tracing the thin black lines that had carried an army across a continent. Each station had done its part, from the disguised pumps of Sandown and Dungeness to the depots at Boulogne and Antwerp. What began as an untested experiment had become the logistical backbone of an entire invasion. A post-war report by Sir Donald Banks summarized it simply. Pluto was a success not of glamour, but of persistence. It was built by men who never sought fame, for a task that could not fail. That persistence had not come without cost. The construction had consumed nearly 100,000 tons of steel, required more than 30,000 workers, and mobilized dozens of ships and factories across Britain. The men who laid the pipelines faced mines, storms, and enemy patrols. Yet the operation suffered remarkably few casualties. The greatest losses, in fact, were mechanical: snapped lines, ruptured joints, flooded valves. Still, the pipeline endured. When sections failed, they were repaired. When storms tore them loose, they were relayed. The flow of fuel, the quiet pulse of the Allied war engine, never truly stopped. As the Allies advanced into Germany and the war in Europe came to its end, the need for Pluto gradually declined. Tankers could now reach captured ports safely, and the pipeline's role diminished. But its achievement had already shaped the course of history. To Eisenhower's staff, it proved that industrial ingenuity could equal military might. To Churchill, it was vindication of his belief that science and secrecy were as powerful as guns and tanks. The German army had been beaten by superior firepower, yes, but behind that firepower was the silent certainty of supply. Pluto was not a weapon, but without it, the weapons could not fight. As peace returned, the cables and pipes that had once carried life beneath the channel now lay dormant, their purpose fulfilled. Few who walked the English coast that summer knew that, buried beneath their feet, the remains of one of the war's greatest engineering feats still rested in silence. Yet for those who had built it, the welders, the sailors, the mathematician, that silence was its own reward. They had built a miracle in secret, and that miracle had won a war. When victory celebrations erupted across Europe in May 1945, Operation PLUTO slipped silently into obscurity. Its pipelines still pulsed for a few more weeks, sending the last streams of fuel toward depots in Belgium and the Netherlands. But as troop movements slowed and ports reopened, the system was gradually shut down. By August, the valves were closed. The pumps fell silent. What had once been a lifeline of war became just another secret buried beneath the sea. The cables and pipes that once carried millions of gallons of petrol were no longer needed. Much of the equipment, the Hayes and Hamel lines, the massive drums known as conundrums, and the pumping machinery, was dismantled or salvaged for scrap. Britain's post-war economy, starved of raw materials, wasted nothing. Yet fragments of Pluto remained. Sections of pipe still lay along the seabed, half buried in silt, stretching from the English coast to the French shore. In some places, fishermen snagged their nets on the hidden steel coils, unaware they were touching the remnants of a secret that had helped liberate a continent. For the men who had built it, there was little public recognition. The operation's classified nature meant few medals, no grand parades, no monuments. Most returned quietly to civilian life: shipyard workers back to docks, cable engineers back to telephone companies, soldiers back to farms and families. Only within the technical branches of Britain's Ministry of Fuel and Power did Pluto remain a subject of study. Reports were written, lessons catalogued, but the wider public remained unaware. For years, the world simply forgot that beneath the waves, one of the war's boldest experiments had taken place. It wasn't until the 1960s, during the declassification of wartime documents, that the story began to surface again. Historians examining the files of the Petroleum Warfare Department stumbled upon references to Operation PLUTO. What they found astonished them. The scale, the secrecy, the sheer logistical brilliance, all had been hidden from view. Articles began to appear in engineering journals. Exhibits followed. Museums along the south coast of England, notably at Sandown and Dungeness, began to recover and display sections of the original pipe and equipment. The public could finally see the machinery that had, quite literally, fueled the march to victory. As veterans grew older, a few shared their memories. A naval officer recalled standing on deck as the conundrum turned, unspooling a black ribbon into the sea under cover of night. An engineer from Siemens described the first successful test, when petrol flowed freely across the channel for the first time. "Like blood through a vein," he said. By the 1980s, Pluto had taken its rightful place in the broader story of Allied innovation, alongside radar, code breaking, and the Mulberry Harbors. Yet even then, it remained understated. Unlike the famous D-Day landings or the Spitfire's dogfights, Pluto had no heroics to dramatize. Its triumph was technical, invisible, and continuous. Today, historians view Operation Pluto as one of the most remarkable feats of engineering logistics in modern warfare, a precursor to the global energy networks that now girdle the planet. It demonstrated how industrial design, when combined with secrecy, coordination, and courage, could change the outcome of war without firing a single shot. On quiet days along the coast of the Isle of Wight or Dungeness, remnants of the old pumping stations can still be found. Rusted fittings, buried concrete foundations, fragments of pipe, weathered plaques now mark the sites. Simple words etched in bronze. From here, under the sea, flowed the fuel of freedom. Those who know the story understand the truth behind that inscription. Beneath the waves once lay the steel arteries of an army, a hidden achievement born of desperation, daring, and determination. And though the world may have moved on, the ghost of Pluto still lies sleeping beneath the channel, silent, steadfast, and eternal. History often remembers its wars through the thunder of guns and the roar of engines. But behind every victory lies another kind of power, silent, unseen, yet indispensable. Operation Pluto was one of those quiet miracles. It never fired a weapon. It never charged a beach. And yet through its buried veins, it carried the lifeblood of liberation. In the summer of 1944, the Allied invasion of Europe depended not only on courage and firepower, but on the ability to keep moving. For every tank that rolled forward, for every bomber that took to the skies, there had to be fuel, constant, reliable, unbroken. Pluto made that possible. Its story is one of imagination turned into reality. Engineers faced the impossible: to send fuel under an ocean, through pressure, salt water, and secrecy, and made it work. Their success proved that wars are not won only by generals and soldiers, but also by welders, cable layers, mathematicians, and inventors who never see the front line. In that sense, Pluto stands for something larger than technology. It represents the spirit of collaboration. British design, American logistics, civilian industry united by necessity and trust. It showed what human beings can accomplish when survival demands invention. Today, few traces of it remain. The pipes rust quietly beneath the seabed, visited only by currents and memory. Yet its legacy endures, in the infrastructure that fuels modern armies, in the pipelines that span continents, in every hidden system that keeps the visible world alive. Operation Pluto reminds us that even in humanity's darkest moments, ingenuity shines brightest when it serves not destruction, but endurance. It was a victory built not in blood, but in silence. A triumph of minds over obstacles. And though time has buried it beneath the waves, its pulse still echoes, a whisper from the deep, telling the story of how men once carried freedom across an ocean, through pipes of steel and will.